This video is all about how to find area of a sector of a circle. And so we'll start by filling out some notes items at the top here. A sector, first of all, let's just kind of talk about what it is. It's part of a circle. And you see it shaded in there. It's part of the area of a circle. So it's this entire wedge-shaped piece. And so a sector is a section of a circle, or you could put part if you'd rather, bounded by a central angle. That's what this is. It's a central angle. So the central angle covers those two sides of the sector. And to completely enclose it, we need the intercepted arc. And then they put it into common people terms. It's like a slice of pizza. And so we need to be able to find the area of a sector like this. And it's going to be a lot like what we did for arc length, where we set up and solved a proportion because it was part of a circle. We're going to do that for area of a sector. The difference is for arc length, it was part of the circumference. So circumference formula showed up in our proportion versus area of a sector. It's part of the area of the circle. And so the area formula will show up. So when I look at this down here, x is the degree measure of the arc, also known as the degree measure of the central angle, since those two things are in fact the same. R is the radius of the circle right there. And the other letter that we will be using is an uppercase A. A is the area of the sector. So my proportion looks like this, the degrees over 360. That's how we're starting it out, same way as last time, same way as arc length. We're typically looking for the area of the sector. And down here is the area of the whole thing, the whole circle, which of course is pi r squared. So that's the proportion we're going to be plugging into and then cross multiplying to solve. I'm going to set up two examples to make sure we've really got this. So pause if you need to write anything down. I'm going to go ahead and erase so I can scroll and continue. Whoops, there we go. First one I'm going to look at is number one. If you're having any trouble seeing it, whoops, there it is. That is a 51-degree angle. It is marked in there. It might be kind of blending if your screen's not high contrast thing. And so to set up my proportion, I know I need 51 degrees out of 360. I'm looking for the area of the sector for each of these. And so A is my unknown. That's the area of the sector. And down here I had pi r squared. Instead of writing r squared, though, I want to put in the radius, which doesn't look like they gave it to me. Always be sure to look up here. BC is 16. That's the radius. So 16 squared. When I cross multiply, same as for arc length, I want to avoid weird numbers, big decimals for as long as possible. I'll start going this way, 360A. And it is an uppercase A because it's standing for area. That's something that we often do. When I multiply this way, I'm going to delay the pi thing for just a minute. I'm going to grab my calculator and go ahead with the 51 times the 16 squared. Whoops, let me try that again. 51 times 16 squared. I got 13,056, 13,056. Now, I didn't touch the pi yet, so it's still sitting here. Don't forget to write it. To get A by itself to solve for the area, I simply need to divide by 360 on both sides. So now on this last step, now that I have a by itself, I change to the approximately equal to. It's just what I do. I can go ahead and multiply it out and everything else. So 13,056 times pi divided by 360, and I get that big old decimal. Up here, the instructions did say nearest hundredth, so it's 113.94 to the nearest hundredth. Oh, and units. Got to be good habits here. If it was feet to begin with, it's area now, so it is square feet. Pause if you need to follow along with that. Okay. All right, one more, whoops. I'm gonna look at number 5 as my final example. Pause the video right now, try it on your own, and then play the video to check your work. That'd be a great idea. Number 5, they are trying to trick us. I will tell you that. Because they gave us the angle for the unshaded part, but they always want the area of the shaded part. And so the first thing I really need to do is make an adjustment. I know the whole circle is 360, so this is easy to do. 360 minus the 42. I'll write it up here to show what I did. 360 minus the 42, because that's the part I don't want, equals 318 degrees, which is the part that I do want. So that's this part. And so that's what goes into my proportion. My proportion has to be about the part that I want, the shaded part. So 318 out of 360, most of the circle, makes sense, equals whatever that area is, over area of the whole circle. Once again, they put the radius up here trying to be sneaky like. Don't let them. Radius is 9, so pi times 9 squared. Cross multiply, I've got 360a equals, going the other way, I'm going to go ahead and do the 318 times the 9 squared. And I got 25,758. And once again, I didn't multiply by pi yet, so it's still sitting there. Don't forget about pi. Divide by 360 on both sides. I'm running short on space here, so I'm just going to do that on my calculator. 25,758 times pi and divided by the 360 gives me a big old decimal to the nearest hundredth. That's the instructions for this. 224.78 for that one. And since my original problem was in inches, my area would be square inches. So there you have it. There's other examples to try. Hopefully they go well.